In this video, I want to talk a little bit about Matlab performance. There's some real basic strategies you can use to speed up your Matlab scripts, and I just want to go through some of those. And then at the end, I'll talk about a tool, a profiling tool that lets you diagnose in a fairly straightforward way which lines are the slowest in your code, and then you can focus on speeding those up if performance is indeed an issue. So as a case study, I thought I'd just generate a bunch of random numbers, and that will allow me to play with different loop sizes and vector sizes and look at performance a little bit. So uh, this command rand generates a random number between 0 and 1, uniformly distributed, and saves it as an element in a vector called x. We do the same thing with a vector called y. So at the end, x and y will be filled with a bunch of random numbers. Then for z, we take the sum of the squares of a pair of those numbers, one from x, one from y, save it in a vector z. So a loop might look like this. This loop generates 500 values of x, 500 values of y, and then combines those to form 500 values of z. So I use a for loop to loop through here 500 times. Then I calculate the mean of z, the standard deviation of z, and then the correlation coefficient between x and y. So how long does this take? Well, I can use my watch to do this, but it's better to have Matlab do it. So there's a pair of commands called tick and tock. I put tick at the beginning. I start a timer essentially, then I run through all the code, and then I end with tock. When tock is called, it gives you the CPU time since tick was called. So this will tell you how long it takes to run this script. For 500 triplets, essentially, it takes about 5 seconds on my fairly old desktop to do this. So why is this slow? Well, the main reason it was so slow is because I didn't have semicolons at the end of these three lines. And so what was happening, it was every time I saved a value of x or y or z, it was displaying the entire vector to the screen, and display is just notoriously slow, so you don't want to do that. So you put the semicolons here. Don't display it as it's calculating. Display it at the end if you really want to see it. Okay, so just that allowed me to go up by a factor of 60 in points. That is from 500 to 30,000, and it took a little less time actually. It went from 5 seconds down to 4. So this is maybe 60 times faster. And that's a nonlinear thing because it's showing all of these vectors every time. So if I needed 1,000,000 points, it would just take forever without those semicolons. So use semicolons until you want to see the output, and then get rid of it. But we can still speed this up further. There's a concept called pre-allocation. The loops before, every time we went through here, each of these vectors x, y, and z were getting one element longer. So every time it had to go and find space from the operating system to save these values. And it's better if you save all the space you need up front and then fill those up later. So here we set x to be a vector filled with zeros that's got n elements in it. And same with y and same with z. So we start out with the vectors, the size will be at the end, but filled with zeros. Then we go and just run through the loop n times and do all the same calculations. And this took about 3 seconds, but I'm up now to 10 to the 7th data point. So it allowed me to go another factor of 300 times more points, and again got slightly faster anyway. So that's a substantial win just by itself. So remember, if you're using vectors or arrays inside a loop, be sure to pre-allocate them so the size is set ahead of time, and that'll save a ton of execution time. There's still more you can do. You can vectorize things and get rid of the loop altogether, and that's what this does. So I set the number of points I want, I start the timer, and now instead of going through a loop and each time through calculating one value of x, I calculate them all at once. So this command, rand of n comma 1, gives me an n vector, n by 1, filled with random numbers in one call. And Matlab has set up these routines to do that quickly. And so it's faster to do that than to do a loop. Okay, so this lets you avoid the loop altogether. And then I can use just vector math to go through element by element, not vector math, but element by element math to go through element by element and add the square of the first element of x to the first element of y, and the second element of x squared to the square of the second element of y, etc. So this dot operator on the squaring command, instead of squaring the vector, it squares each element individually within the vector. So it does element by element math, squares each element, and then adds those two vectors together. So this one command gives me a vector z, which is the sum of the squares of each element in the corresponding spots in x and y. So this gives me the squares of the elements, and then I could sum that up if I wanted to and get the sum of the squares if that was of interest. So this command gives me all the values of x in one shot. This gives me all the values of y in one shot. This gives me all the values of z in one shot. I was able to double the number of points again and get about the same time, 4 seconds versus 3. So it's not quite twice as fast to do this once you've optimized those loops, but still it's better to do without the loops if you can get away with it. And to me, the code is cleaner now, especially once you get used to this this element by element math, for example. All right, so those are just some basic techniques you can use to do this. There is one other thing I wanted to show you. Okay, so here's my Matlab window, and I've got the editor here, and it's buried in the Matlab window. So the output is over on the right, the command window, and the editor is here. And one thing to note is these little orange bars. This is a fairly new version of Matlab, R2009B. And if I highlight these little orange bars, it'll give me some profiling or some performance hits. So this one says if you terminate this line with a semicolon, you can suppress the output and things will speed up. So you can even just fix that immediately. Okay, so I could look at all these down here. I guess right here it talks about the pre-allocation, right? It says the size of y is changing each time through. So these little orange bars will help you catch some profiling errors. And then the other thing you can do is go desktop profiler. And I've already run this, so I put the name of my script here and executed it, and it took a little while. And then it shows me all of this. So you can see that line number 6 in my script took 15% of the total execution time, okay? And line number 5 took about 11%, right? And so those were the two commands that were displaying the output to the screen. Same with Z. So just those 3 commands took almost half the total execution time of the script, just because that display of graphic information is so slow. Okay, you can also scroll down and you see these are the emlet results, and those are those things that were little orange hints that were in the editor. So you can see on line 3 it's suggesting you might want to use a semicolon. On line 5 it's suggesting you want to pre-allocate. So all this repeats what was highlighted by those little vertical orange bars in the editor. That's useful information. Then there's some overall information about the number of lines in the code and that sort of thing. And then down here it goes line by line and gives the execution line for each. So you can say that it colors in red the slowest ones, and line number 6 seems to have been the slowest. And then from here you can actually click here and it'll bring you right back to that line, and then you can fix it if you want. Okay. So the profiler helps quite a bit too. So try to keep in mind those hints I gave you earlier, but overall the profiler can help you with a lot of that. And anytime your scripts are running slow, you should check these hints in the editor and also take a look at the profiler. All right, so good luck with that.